a linear time invariant system is characterized by the differential equation 4d squared y over dt squared plus 5dy over dt plus y is equals to exponential negative t. T is 0, y is 0, and dy over dt is 0. So you've been told to solve that given differential equation using Laplace transform. So for you to use Laplace transform, you introduce Laplace on both sides of the equation, isn't it? So if you introduce Laplace here, you factorize out the constant for Laplace transform of d squared y over dt squared, isn't it? Then it is plus 5 is a constant, so it is plus 5 Laplace transform of dy over dt, then plus the Laplace transform of y to be equals to the Laplace transform of exponential negative t. Having introduced the Laplace transforms, the next thing you do is to get the Laplace transform of each and every part, isn't it? So before you get the Laplace transform of each and every part, you can list them of course. When you are differentiating y with respect to t, it simply implies that y is a function of t, meaning y is y of t, isn't it? So if you differentiate y with respect to t, you get dy over dt, and if it is a function, it is denoted as y prime of t, isn't it? Yeah. Are we together? Yeah. And you'll be told this y is equals to what? And you'll be told this dy over dt is equals to 1, and you'll be told t is 0, meaning anywhere you see t you put 0. So you have transformed the initial conditions with in terms of the Laplace notations, isn't it? So you start. What is the Laplace? The first one. What is the Laplace transform of d squared y over dt squared? We said when it is the second derivative d squared, you start with s squared, isn't it? Then Laplace of y, what is the dependent variable, isn't it? Then Laplace of y. Then after s squared, it is now s raised to power 1, which is just s, isn't it? Then y of, what is the variable in the numerator is what we are interested in, isn't it? See, then y of 0. Then the next one is now minus s raised to power 0, isn't it? See, that means s is not there. Then you differentiate y of 0, you get y prime of 0. It means s is what is guiding you, isn't it? Yeah. S raised to power 2, s raised to power 1, s raised to power 0. Meaning at raised to power 0 is the end, isn't it? Yes. Are we together? See, we are done with this. We move to this other one. The Laplace transform of dy over dt. The Laplace transform of dy over dt, meaning the derivative here, it is d raised to power 1, isn't it? Yeah. So when it is power 1, it's just s, isn't it? Yes. Then the Laplace of y, that variable is the numerator, the dependent variable, isn't it? Then Laplace of y, then it is minus, this is s raised to power 1, the next is s raised to power 0, isn't it? Then y of, remember Laplace is only in the first part only, isn't it? The rest are y of 0 and its derivatives. See there? Are we together? Yes. So yeah, s to power 1, s raised to power 0, that is the end, isn't it? Yes. Are we together? Yes. Then the next one here is Laplace of y. It's already Laplace of y the way it is. We don't need that, isn't it? Then the next one, Laplace of exponential negative t. We get that because that is the independent variable, isn't it? So what is the Laplace transform of exponential negative t? When you have the Laplace transform of exponential negative at, you are supposed to get 1 over s plus. If here is minus, there is plus, isn't it? Yeah. So it means your a is 1, isn't it? Yes. Your a is 1. So the Laplace transform of exponential negative t is 1 over s plus 1. So you have found the Laplace transforms of each and every part, isn't it? Yes. Are we together? Good. Remember, this part of solving the differential equation, it will always be 10 or 11 free marks, isn't it? It is the other part A, whereby you will take your time, like this lady was calling for time, isn't it? Yeah. You will have to take your time. Are we together? Yes. And to digest it accordingly, isn't it? Yes. Sometimes this one will go to 13 marks, then the other one 7. And out of 7, you will always get 5 marks and above, isn't it? If you don't want all the marks. Good. So the next thing we found everything, what we are doing is substituting. And before you start substituting, y of 0 is 0, isn't it? Yes. So it means the whole of this will go to 0. And y prime of 0 is 1. Meaning this one will be 1. Y of 0, this one will be 0. Are you seeing? Yes. Are we together? Yes. So you're seeing here your y of 0 is 0. Where there is y of 0 is 0 times anything, the whole of this will be 0, isn't it? Yes. But your y prime of 0 is 1. This one will be 1. Okay? So can you now substitute back in the equation? In the equation we have 4 into the Laplace transform of d squared y over dt squared. This 4 into this, isn't it? So it is 4 into s squared Laplace of 4 into s squared Laplace of y. This one is 0 minus 1 because y prime of 0 is what? Are we together? Yes. See where this is the Laplace transform of d squared over dt squared, we've substituted this is equal to s squared Laplace of y minus 1 minus 0 minus 1, isn't it? Yes. Good, you are done with that. Then you go to the next one, plus 5. Then in bracket, substitute what is the Laplace transform of dy over dt. It is s Laplace of y minus 0. So that is just s Laplace of y, isn't it? S Laplace of s Laplace transform of y. Then the next one, plus Laplace transform of y is just Laplace transform of y, the dependent variable, isn't it? So it is plus the Laplace transform of y. Then it is equals to what?
1 over s plus 1.
Yes, Laplace of transform of exponential negativity is 1 over
S plus 1.
Yes, 1 over s plus 1. So the next step is to open the brackets, isn't it? So 4 multiplies everything inside the bracket, isn't it? So 4 times that? 4s squared Laplace of y. Then 4 times negative 1?
Minus 4.
You've opened that bracket, isn't it? Then open the other bracket. Positive 5 multiplies everything. 5 times s. 5s Laplace transform of y, isn't it? Then plus Laplace transform of y is equals to. So after opening the brackets, the next thing, you take any term without the Laplace transform of y on the other side, isn't it? So here we remain with 4s
squared Laplace transform of y.
4s squared Laplace transform of y. Negative 4 goes on the other side, isn't it? Because it does not have Laplace transform of y, isn't it? Are we together? Yes. Then it is meaning you are collecting the terms with the Laplace of y only to remain on this side, isn't it? Yes. Then plus
5s Laplace transform of
5s Laplace transform of
y
plus
Laplace transform
of y is equals to 1 over s plus 1. Negative 4 going to the other side, it becomes positive 4, isn't it? Meaning on the other side of the equation, we are going to look for the LCM, isn't it? So here, you factorize out Laplace transform of y because it is a common factor, isn't it? That's why you are only leaving terms with the Laplace transform of y on this side of the equation. So if you factorize it out here, you get 4s squared plus
5s
plus 5s plus
1
plus 1, then into Laplace transform y, the common factor, isn't it?
Yes.
To be equals to the LCM there is
s plus 1.
s plus 1. S plus 1 goes here 1 times 1 is 1, then plus, isn't it? Then 4 into 1 goes here
Plus 1.
s plus 1 times 4, you get plus, isn't it? Are we together?
Yes.
So the next step will be
Open
the Laplace transform of y. If you open this bracket, 4s plus 4, isn't it?
Yeah.
So 4 plus 1 is
5.
5. So it's like we're going to have 4s plus 5 over s plus 1. Then you are dividing both sides with this denominator, isn't it?
Yes.
Meaning it is times 4s plus 5s plus 1. Are you seeing? This numerator, if you open it, is 4s plus 4 plus 1, it is 4s plus 5. Then over s plus 1. Then you are dividing both sides with the base. Because this is the point where you divide both sides with the base. Then you remain with the Laplace of y. Are we together? Isn't it?
Yes.
After that, you check. If this cannot be factorized into linear factors, you leave it as a quadratic factor, isn't it?
Yeah.
So go to that calculator, meaning you don't set the calculator to complex. Go to setup. When you go to setup, then go to equations. Are you in equations? Click setup. You've seen the equation
EQN.
Yes. When you click equations, quadratic is number. You see quadratic equation is given there nx squared plus bx plus, isn't it?
Number 3.
And this is quadratic equation. It is 4s squared plus 5s plus. It is number 3. So when you select number 3, it is going to tell you to key in. Select that quadratic. It is telling you to key in the value of a, isn't it? So key in number 4. You pressed A, you key number 4, isn't it? Press equal sign, then it will tell you to key in the value of B. B is positive 5. Key in number 5. Then it will tell you to key in the value of C. C is positive 1. Key in the value of C. When you press equal sign, it will give you the first answer. So when you press equal sign, what's the answer?
-1.
-1/4, meaning the first value of S is equals to -1/4. When you press equal sign again, it will give you, because there it is giving us X, but here we have S, meaning where the X we put S. Are you see?
Okay.
Then if you press equal sign again, what is the next answer?
-1.
-1. So this is what is happening. When you now want to get the two factors from this equation, this is what you do. You start by multiplying by what is in the denominator form. Are you seeing? Multiply both sides by 4, you get 4s is equals to -1. Then here there is no denominator. Then it's now when you bring the other term this side. So you have 4s plus 1 is equals to 0. You bring -1 here, you have s plus 1 is equals to 0. So it means either this factor or this factor is equal to 0, meaning this a product of these two factors is what gives you that. So you go and put it there. It is 4s plus 5 over s plus 1. Then if you factorize this, you are getting this factor and this factor. Are you seeing how to get them? So the factors you have there is 4s plus 1 and s plus 1. The manual list, you can also do your manual thing. The manual list, when you are factorizing 4s squared plus 5s plus 1, which numbers give you a product of 4 and a sum of 5? 4 and 1, isn't it?
Yes.
So you get 4s squared plus 4s plus s plus 1. Here you have 4s as a common factor, you remain with s plus 1. Then here you have 1 as a common factor, you remain with s plus 1. So if you take that, it is 4s plus 1, it is s plus 1. That is what you have there. So you are not going to waste time looking for a product, because sometimes there are SARs. You know what we are interested in is real factors. It doesn't matter whether it is an integer or a SAR. So yes. We are interested in the real. That is why that calculator is important, because in this case they were cases of integers, product and sum of 1 and 1. But you will find cases when you are not able to see them, isn't it? So when you are not able to see them, what do you do? See, you go with that method. Or you use the quadratic formula and still that method, isn't it? Yeah, and you get them. Those real factors is what we are interested in. If they are not real, they are complex. Okay? If they are not real, they are complex. So what is the Laplace transform of y? It is 4s plus 5 over s plus 1 times s plus 1. See, that is s plus 1 squared. See, that's multiplied by itself.
Into 4s.
Into 4s plus
1.
So what do we do?
That is, we apply there a plus.
Yes, we resolve into partial fractions, isn't it? Yeah. So here will be the first factor s plus 1 is a linear factor. We just repeated itself, isn't it? Yes. So it is going to be a over s plus 1, then b over s plus 1 squared. You repeat it until you exploit its highest power, isn't it? Are we together? Yes. Because s plus 1 is a linear factor. This 4s plus 1 is also a linear, because the power of s is 1. The power of s is what dictates. When the power exponent of s is 1, it is linear. See there? Yes. 4s plus 1 is also linear, meaning it is going to be c over 4s plus 1. Are you seeing? Yes. Then what is the LCM? The LCM is what you have here, isn't it? Yes. It is s plus. The LCM there is s plus s plus 1 squared into 4s plus 1, isn't it?
Yes.
So start. S plus 1 goes here how many times? It is A, you remove 1s plus 1, isn't it? So it goes s plus 1, 4s plus 1 times, isn't it? Then here we have plus b, then you go again. S plus 1 squared goes here how many times? 4s plus 1 times, isn't it? Are we together?
Yes.
4s plus 1, then we have there plus c, then 4s plus 1 goes here how many times? It goes the remainder s plus 1 squared times, isn't it? S plus 1 squared times. Are we together? So you know very well that when you have linear factors, you don't compare the coefficients because linear factors you will always take it to 0, isn't it? So linear factors you start s plus 1, meaning if s is negative 1, you get 0, isn't it? You are comparing the numerator. The denominator is the same as the numerator, meaning this numerator is the same as this numerator, isn't it? Yes. So what you are comparing is 4s plus 5 to be equals to this numerator. A into s plus 1, 4s plus 1, then plus b into 4s plus 1, then plus c into s plus 1 squared. The numerator must be the same as the numerator because the denominator is the same as the numerator, isn't it? So start. When s is negative 1, you will get a 0, isn't it? So start there. When s is equals to negative 1, what do you have? Negative 1 times 4?
Negative 4.
Negative 4 plus 5?
1.
Is 1. Is equals to negative 1 plus 1 is 0. The whole of this will go to 0 because 0 times anything, the whole of this part goes to 0, isn't it? Yes. Then negative 1 plus 1, the whole of that part also goes to 0, isn't it? Yes. See what you remember there? Negative 1 times s times 4? Negative 4 plus 1?
Negative 3.
Negative 3 times b?
Negative 3b.
Negative 3b. Then here negative 1 plus 1 is 0. We take the whole of that to 0, isn't it? Yes. So what is the value of b? Negative a third. You divide both sides by negative 3, isn't it? You are done. Which other one takes them to 0? Here. 4s. You multiply by negative 1 over 4, isn't it? Because negative 1 over 4 times 4 is negative 1. Negative 1 plus 1, see that is 0. See when you make s to be negative 1 over 4, you get negative 1 here, isn't it? Then negative 1 plus 1 is 0, isn't it? Yes. So when s is?
Negative 1 over 4.
Yes, when s is negative 1 over 4. So where you have 4s plus 1 will be 0. So it means the whole of this term will be, the whole of this term 4s will be negative 1 plus 1, 0, isn't it? Yes. Alright, start this side. What do you have? 4?
It's 4.
4 times negative 1 over 4?
1.
Negative 1. S is negative 1 over 4.
Yes.
Negative 1 plus 5?
4.
4. Good. The whole of this will be 0 because of 4s is negative 1, isn't it?
Yes.
Negative 1 plus 1 is 0. That, the whole of that is 0, the whole of this is 0, isn't it?
Yes.
Then you remain with this. Sit down. Yes. Negative 1 over 4 plus 1? 3 over 4, isn't it?
Yes.
Sit down. Yes. 3 over 4 squared?
Is 9 over 16.
9 over 16 times c is 9 over 16c, isn't it? Yeah. Are we together? Yes. So what is the value of c? C, you multiply both sides by 16 over 9.
Yes.
By 16 over?
9.
Over 9. And you get 64 over? 64 over?
64 over 9.
64 over 9. You found the value of c, isn't it?
Yes.
See, once you found the value of b and c, you now choose any number, isn't it?
Yes.
And which number is easier to choose?
0.
0. Yes, because there's no 0 here, isn't it?
Yes.
When s is? 0 is always the easier to choose before you move to 1, isn't it?
Yes.
So when s is 0, 0 times 4 is 0, you remain with this side is? 5. Is equals to s is 0, you remain here with 1, 1. 1 times 1 is 1 times a, isn't it? Yes. So you remain with a. Yes. Then you move 0. 0 times 4 is 0 plus 1. This is just 1, isn't it? Yes. 1 times b is b, and b is? Negative 1 over 3. Then 0 plus 1 is 1, 1 squared is 1. 1 times c is c, and c is?
64.
Plus 64 over? So what is a?
5 minus 1 over 4.
It is not 5 minus 1 over 3.
Plus.
Yes, 5 negative 1 over 3 can be there is 5 plus 1 over 3. Then minus 64 over. Send it off.
Yes.
Minus 64 over 9. What do you get?
We get negative 16 over 9.
Negative 16 over 9. So we found the value of A, B, and C, isn't it? So the Laplace of y is what? The Laplace transform of y is equals to A over s plus 1, isn't it? A over s plus 1. And what is A?
Negative 16 over 9.
Negative 16 over 9 over s plus 1. You factorize out negative 16 over 9, isn't it? Then it is plus b over s plus 1 squared, isn't it?
Yes.
What is b?
B is
Negative 1 over 3 over 1 over s plus 1 squared. Meaning you factorize that one outside the bracket, isn't it? You see, we are now ignoring those steps.
yes.
Then you move to the next one. C over 4s plus 1. And C is what? Plus 64 over 9. Then in bracket we have 1 over 4. 4s plus 1. Remember, this is 1c. So you have factorized c outside. You remain with 1 over 4s plus 1. Isn't it? Then here is 1b. You have factorized b outside. You remain with 1 over s plus 1 squared. Isn't it? Are we together?
Yes.
Good. So what do we do? For us to get y, we take Laplace the other side, isn't it?
Yes.
When we take Laplace the other side, we remain with y. And y is the same as y of t, isn't it? You remain with y is negative 16 over 9 is a constant, then it becomes Laplace inverse. See there?
Okay.
Laplace inverse of 1 over s plus 1, isn't it?
Yes.
Then negative 1 over 3, Laplace inverse of 1 over s plus 1 squared, isn't it? Then plus 64 over 9, Laplace inverse of 1 over 4s plus 1. Can you deal with each and every part and tell me what's the answer? Start with this one. The Laplace inverse of 1 over s plus 1. So that is exponential.
Yes.
Yes. When you have the Laplace transform of exponential negative at, you are getting 1 over s plus a, isn't it? When a is negative, a is positive, isn't it?
Yes.
And when you have Laplace transform of t times exponential negative at, you are getting 1 over s plus a. We proved that, isn't it? Yeah. So it means this is your 1 over s plus a squared. It is already here, isn't it? Then, so start with the first one here. The Laplace, when you take Laplace things, the other side you remain with exponential minus a is the Laplace inverse of 1 over s plus a, isn't it? So when you have exponential, so if you have 1 over s plus a is 1, isn't it? When a is 1, you have, where there is a, you put 1, you have 1, that, isn't it?
Yes.
So it means Laplace inverse of 1 over s plus a is exponential negative 8, isn't it? Then you move to this one, you see it is this, isn't it? When you take Laplace, the other side you get t exponential at is the Laplace inverse. Laplace when the other side becomes inverse, isn't it? Laplace inverse of 1 over s plus a squared, isn't it? Are we together?
Yes.
So here you have 1 over s plus 1 squared, meaning your a is 1, isn't it? So where there is a, if you put 1, you remain with the exponential. This is negative, senor. It is exponential negative 80, senor.
Yes.
So where there is a, if you put 1, you remain with just t. Where there is a, if you put 1, you remain with that. So it means the Laplace inverse of 1 over s plus 1 squared is just t exponential negative t, isn't it? Then this last part, look at it. The Laplace, it is just the same as that. So this is what you do to it. If you have 1 over 4s plus 1, so you remove 4 outside. So that is 1 into 4 into s plus 1 over. If you remove 4 outside, isn't it?
Yes.
So it means we are going to factorize 4 outside. So 4 times 9 is going to be what? 36. Then you remain with s plus 1 over 4. Are you seeing? Because s does not have a coefficient, you remove 4 outside. Meaning where you have 4s plus 1 is the same as 4 into s plus 1 over 4. Then that 4 which is here will multiply because it is in the denominator, isn't it?
Yes.
So it multiplies what was in the denominator. Then you get 36, and you know 64, 36 will, of course, will simplify, isn't it?
Yeah.
So we are looking for the Laplace inverse of this, meaning your a is 1 over 4. Isn't it? Are we together?
Yeah.
And it is the same as that, isn't it? You say the exponential at is the Laplace inverse of 1 over s plus a. So your a here is 1 over 4. Well, then you say you put 1 over. Serio? Are we together?
Yes.
So you substitute them here. So you get y all y of t because y is the function of t. Serio? Still the same. It's 1 over negative 16 over 9. Laplace inverse of 1 over s plus 1. You found this exponential. Exponential negative t. Negative t. Then here you have minus 1 over 3. Laplace inverse of 1 over s plus 1 squared is what? T exponential. Oh, it is this one. T exponential negative t. Then here 64 36 in simple form. 16 over 9. Then Laplace inverse of 1 over s plus 1 over 4. You found this exponential. Negative 1 over 4 t.